Hello and welcome to my shed. What I want to do today is show you my robotic arm. It's 6 degrees of freedom robotic arm constructed from foam core board and servos. Let's have a closer look. Okay, we have 1, 2, 3, 4, 5, 6, 7 different servos. There's a servo in the bottom which allows us to transfer horizontally. The main servo, sort of the shoulder one, is in there. We have an elbow, a wrist, and a twisty one, and then two which form these jaws, open and close to grasp things. I believe this gives us 6 degrees of freedom. So the servo in the bottom, this one, 2, 3, 4 are fairly big chunky servos. You can see there. Let's get a bit closer and see if we can have a closer look at that. There we go. Let me see that. Let's get some light in there. There. The arm itself is constructed from foam core board, normally used for posters or architectural models, but it's quite strong in this case. A bit heavy, but that's something we need to find out. Now, originally this was supposed to be controlled through these server leads through a board linked into a computer, maybe a Raspberry Pi. That was the idea, and but we don't have that yet. So what we're going to do, as they're servos, I'm going to plug them into my transmitter and receiver, 6-channel receiver, and see what we can do, see if we can power them through that. So bear with me. Okay, here we have the wires coming out of the robot arm, and here we have the 6-channel remote control from a model aeroplane kit, to be honest. Now, the wires coming out of the servos have 3 wires: black, red and white. The black and the red supply the voltage to the servo. It's normally about 5 to 9 volts depending on how big the servo is, and how much the receiver can actually pump out. I believe this one can do about 5 volts or so. I can't read that on there, but never mind. Now, I'm not too bothered about what order these go in, as long as the white wire, which is the signal wire, goes in the right end. So let's just plug these in, and I'm not going to plug in the base one because I've actually got 7 servos, because I need 2 servos to do the jaws. And are they all in the right way around? Yes. Got a hole there. That one goes in there. And that one. Now, in the final product, this is not supposed to have. It's not going to be run off a remote control. It's going to be run, hopefully. The original plan was to run it off joysticks, but joysticks don't have enough. I need 3 joysticks, which is a bit weird because you need 3 hands. So my solution at the moment is to run it off a series of 6 switches, but we'll get to that. So I need to power. Now, this power brick here is just another power supply from the model aeroplane, which will regulate the power from the LiPo down to what the servo can deal with. So that's the power brick. I need a LiPo, which I can't connect yet, and I need my transmitter. So here's the transmitter, and we get that lined in there. Look at that. Now this does tend to make bleepy noises. I'll plug it in. So let's go see what happens. There we go. That seems to be working. So let's see what happens when we plug it in. And in fact, you can't see it, so I'm going to have to pull back for a long shot, so bear with me. Okay, here we have the transmitter. Bit bleepy, makes noises when you don't have inputs, just like that, so just bear with me, that's fine. We have the power brick, which is supplying, which will be when I've connected the LiPo to it, supplying the receiver with power, which should send signals to all the servos and tell it what to do, so that we can twiddle the knobs on the transmitter and make it do stuff. Won't that be great? So let's see what happens when we power it up. When we power it up, all the servos will zero. I expect all the servos to get a volt, to get some power, and will go into will zero all the servos. So let's do black wire first, and well, that seems to work. Now let's see what happens when we move the transmitter. Not much happening there. Now I don't know where these wires are wired up to, because at the moment they're just wired up to random ports on the receiver, so we'll have to see. That doesn't look very good. Now I've got no control. It's just spazzing out. And I can see, if you look here, can you see that red light flashing on and off? That is the receiver resetting itself. So I don't quite know what's going on here. I'm going to cut it off. So, that doesn't look very good. What I think's happening here is the servos are pulling too much load. This is rated for 2 amps. So if the servos are pulling more than 2 amps from this, it's going to reset. And as it resets, it puts all the servos back into their standby positions, and it doesn't do anything. So that's the problem we've got to solve. So, what was the matter? I think the receiver is resetting itself because the servos are drawing too many amps through it. In fact, that's warm actually, which is just for that small amount of time is it must have been trying to pull quite a few amps. Now each of those big servos is rated at 2 amps, and I'm not sure. I think this is a 2 amp receiver, so that may explain why it's struggling a little. Now, what we can do, because the way servos work, let's have another look at one of these wires here. We've got the black, the red and the white. The white wire is the signal, and that's what we're interested in. So if we can supply power to this some other way, 5 volts, 10 volts, I think these 5 volts will do. So if we send 5 volts through this, but we still have the signal wire, we don't necessarily need to take the power from the receiver. We can supply power to the servos through another means, but as long as we take the signal, it'll still tell the servos what to do. Now that's what we have to build, and that'll probably be in the next video. Thank you very much.